So another calculation we're going to look at is something called the effective rate of interest. So compound interest rates, depending on when they are compounded, whether that's semi-annually, monthly, they're not necessarily comparable unless you actually create them as an equivalent rate. So there is something called the effective rate of interest, where it basically makes things comparable using the compound periods and creating an equivalent sort of annual compounded rate. So there's reasons for this happening. One of the reasons why is that legislation surrounding lending and credit practice requires the lender to publish the basically what we call the true cost of borrowing. And a lot of people disclose this as what we call the effective rate of interest. So again, just making them comparable using the compound periods related to it. So our formula related to that is that the effective rate of interest, also known as the effective annual rate, is the following. So we have EAR, which means the effective annual rate or effective rate of interest, and is the following. So notice there's two embedded brackets here. So order of operations is extremely important. The only two values that you really need to have are the I and the M value. So you need to have your rate relative to compounded period to the exponent of your compounded period minus 1 multiplied by 100 to get it in percentage format. So again, let's do an example of seeing how we apply this formula to create an effective rate of interest. So here's our example. Find the EAR, so effective annual rate, for a loan with an annual interest rate of 12% compounded monthly. So we have all the information we need to do that calculation. So our formula is EAR is equal to, and square bracket, 1 plus I, and you're going to need to do that to the exponent m, then your minus 1. After you've done that, then you multiply by 100. So it's important to make sure we do step 1, the inside bracket, step 2, do the exponent, step 3, subtract, and then step 4, only at the end will we do the multiplication. So off to the side, let's talk about what values we have and what we need to do any kind of calculations with. So our rate of interest is 12%. So we know we want to put that in decimal format, so 0.12, and it's compounded monthly. So that's 12 periods per year. And then we know we want to calculate our I value. So I, remember, is R divided by M. So 0.12 divided by 12, and we'll take that whole thing and plug it into our formula. So we need basically these two numbers to actually find our effective rate of interest. So substituting in, so we have a 1 plus I, 0.12 over 12. That whole thing is to the exponent 12 minus 1, and then multiply by 100. So please watch your order of operations carefully. I'm going to go step by step and show you that process. So first off, inside my bracket, so 1 plus 0.12 divided by 12. So you get 1.01 to the exponent 12 minus 1 multiplied by 100. Keep that in your calculator. Square that value, so you should end up getting 1.1268, etc., etc. When you do your exponent, minus 1 times 1,000, sorry, not 1,000, 100. So minusing 1, we're going to get 0.1268, etc., times 100. And you end up getting approximately 12.68 to 2 decimal places %. So yes, it is 12%, but that's compounded monthly. So to make it relative, we calculate the effective rate of interest, which is 12.68.